Hi everyone, and welcome to another Memgraph community call. I see people are slowly joining, so I will first do a small introduction. So to start with, let me tell you that last week we had another event on a similar topic of GraphRAG, but a bit of different approach. This was with my colleague Ante. So in case you missed it, check out the recording of Agentic GraphRAG. He did a cool demo and I guess you can learn a lot from it. So it will be a valuable resource to learn from. But today, as you can see, I have Jacob Coles with me. So Jacob is a data scientist from Redfield. Redfield is a consultancy company that deals with a lot of different use cases that Jacob will tell you more about, but mainly what's related to us is graph analytics and RAG applications and similar to that. So he will tell us more about that and himself. But today he will talk about GraphRAG global search with hierarchical modeling. But kind of to translate into simple terms, he will show us how you can have chatbot answer more global questions that are, and this is achieved with something that is motivated with Microsoft GraphRAG, as Jacob will be using Leiden community detection, which was recently implemented in Memgraph. So I'm really looking forward to learn how he did this. I'll get to learn a lot as well. And I guess if you have a question from Jacob during this presentation, please post it in the Q&A tab. That's the one with the small question mark, because it will be easier for me to highlight it later for Jacob. If you have a general question or just want to chat, you can use the chat. And there will be polls posted in the poll section. And yeah, I think that's it. This was a small introduction from my side, but I guess now, Jacob, the floor is yours. And thank you for joining this call. Thank you for agreeing to do that. And thank you for agreeing to share the knowledge with the Memgraph community.
Thanks for the introduction.
No worries.
So as Katarina said, we'll be getting into a bit about how we've managed to do GraphRAG with hierarchical modeling based off the Microsoft RAG implementation. So maybe I'll just jump into the presentation then. That'd be the best way. Okay, if no one says anything, I'm assuming that everyone can see my screen.
It's all okay.
That's great. So actually, maybe it's best to do a bit of an introduction on our company and who I am. So I work at Redfield. We're a small consultancy based in Stockholm, Sweden, and we have expertise in graph analytics, machine learning, data science, custom chatbots, RAG applications, and so how that's all tied together, and API development. We build a lot of custom solutions for our clients. So everything we work with, it's a lot of smaller custom sort of jobs, proof of concepts, and some of them get developed into prototypes. We also do training programs, etc. But maybe more interesting today is getting into the topic. So we're talking about the comparison of a naive RAG approach and a GraphRAG approach with global search. So I don't know if I can ask a question, but is everyone in the audience somewhat familiar with how sort of regular RAG works? Or I will be giving a little bit of an overview of that as well, but I'd like to know how much I should go into detail.
Yeah, we'll see. We'll see if anyone will respond. Feel free to type in the chat so
Yeah,
Jacob is more familiar, with your knowledge.
Exactly, and especially if I'm going too quick or anything. But so that'll be what we're getting into today. We'll also focus a little bit on the new features of Memgraph 3.0 and how that's enabled us to be able to do this as well. So yeah, let's get started with it. So firstly, I'll get into what a so-called naive RAG approach is. So this is basically retrieving information from a database to get information, and then using a language model to answer a question based on that information. So we usually retrieve documents with a simple search. Usually we use embeddings to get documents that are semantically related to the question that we're asking. And so that comes in two stages. Before we can even query, we have to go through the whole indexing process. So we split documents into manageable bite-sized chunks we can use a language model, like a large language model, to get embeddings, which is basically some type of semantic or meaning representation of the text. And then we upload that into a vector database so that we can quickly, when a question is asked, we'll be able to fetch the relevant documents based on whether or not certain documents are similar to our question or not, so that we don't have to deal with the sort of context window problem of language models as much. So as I said, the querying process, a user's question is turned into an embedding using the same model that you would use to create the documents in your vector index or vector database. These chunks are retrieved as text, and then we paste those chunks into the context window of our language model, kind of like ChatGPT, and then we can ask questions about those context chunks that were sort of fetched. And again, this is primarily just because we have a context size issue, where if the context is too long, it can be easy to lose focus of what is relevant in the context. And also, language models just can't have infinite context, although there have been models that have been with quite large context windows. But it's also about efficiency and speed too. So this is how they work, basically. But the problem is we're still limited to specific bite-sized chunks of documents, and you're sort of hoping that when you're searching for something, you'll find a specific document that has all the information you want, where usually information could be split up between different bits of documents. Now let's move forward a little bit and try to move towards something that's a little bit more connected. So now we can look at how we can use GraphRAG, which is a way that we can build up a database index of connected information from documents as well. So this is not getting into the key part of what we'll be talking about today with our sort of global search, but we'll be getting there. So I'll just talk about the more regular sort of GraphRAG, and as Katarina mentioned, this was gone through in the previous community call. So if you want to get more into that specifically, you can have a look at that as well later on in the recording. But in regular GraphRAG, in this case, what we do is we go through documents, we extract subject, object, and relationship through those documents, and then we're able to have this type of relationship where we will have some sort of free text, and then we can extract this, this, and this. And that enables us to basically, if we can do that enough in the documents, we can then build up a graph database from that. So that's what this indexing process is with regards to GraphRAG. We go through, we index the documents by reading the documents, extracting the triplet of subject, relation, and object. We then have to resolve common references of things. So for example, if Steve Jobs was mentioned in multiple documents, those would basically be the same node, or they should be. And then all of this is uploaded to a graph database, just like Memgraph, for example. And then once we've got that indexed, then we can search. We can use different graph analytics tools like Memgraph Labs, along with different query languages like Cypher, which is super easy to use compared to other sort of query languages for finding sort of long-range dependencies and relationships between data. You could use generating graph queries like Cypher using a large language model. So you might just ask a question, and then you might not even know how to write that query language, but you might be able to retrieve the information anyway. So that's another technique you can use. And then there's also vector search. So you could actually do the exact same thing as what we're doing in regular RAG as well, where you take the entities, you put them through the language model to generate an embedding, and then you can search for those. But then in a way, you still end up with the same problem, which we'll get into the next slide. So that is that knowledge is still limited to specific localities within the graph. So we can only fetch information about specific entities or document chunks. So we don't have this large scale generalizations over the entire graph, just simply due to the fact that all we've done is extracted entities and relationships from specific parts of the documents. And it is connected. And if you're spending enough time looking at it, you could definitely search through the graph and find those interesting relationships. But as it is to begin with, whenever you're looking at a portion of the graph, you're only looking at that small portion of the graph. And in terms of when we're working with fetching documents from a graph database for answering questions. So that really gets more into the long distance dependencies. That's more of an issue there, where, for example, if you have, you're trying to ask a question about information that's contained within a graph database, and you have one node that's very close to another one, you might be able to do some local search to find the relevant information. But if there's long range dependencies, that might not be as straightforward to do. So we still have these same issues where we might have a limited context window. We might be fetching too much from the graph database to be able to answer a question that's generalizing over the whole thing. And for example, queries like, what are the top 5 themes in the book perform poorly since a vector search looks for semantically similar text content within specific pieces of text. So again, thinking back to if you're using a chatbot where you've got this GraphRAG approach happening in the back end, you might ask a question, and if you try to fetch information from the graph database, it might be hard to unify all these different pieces of information. So the solution to that is, in part, the Microsoft GraphRAG implementation, which has this type of global search, as it's called. So this is a paper that was released last year. You can go ahead and look at that if you would like to. But in general, it builds on top of that existing GraphRAG architecture where you're extracting entities from text and building up a graph of that. But on top of that, there's extra work that's being done to be able to make generalizations over the entire graph. So the way that's done is by using this technique, by using Leiden community detection. So this is a way of basically grouping pieces of knowledge within the graph. So what this essentially does is groups entities based on how connected they are to each other. And then and it does this in a hierarchical way, such that it's hard to explain this perhaps, but entities are not just simply clustered in a way. They've also got different levels of clustering. So there will be sort of low-level clusters that will be collecting different groups of entities specifically with each other, whereas there will be higher-level clusters. Clusters technically isn't the right word, I don't believe, but communities that group together different communities with each other. At least conceptually, that's the way that I would think about it if it's difficult to sort of get your head around how to combine this sort of idea of hierarchy plus graph. But so community summaries are what we build up next. So once we build the communities, which is basically a collection of nodes, we then have to create a summary of that community, which then represents the meaning of that entire community. I'll be getting into more of the weeds later on, so if that's a bit confusing now, don't worry too much. And then once we've built up these communities of groups of nodes within the graph, and again, there's hierarchical levels to it, so it's just we're able to search over those communities instead of just searching over the individual nodes themselves within the graph that represent entities. So let's go ahead. So our approach, we've basically used Memgraph with some tooling from LlamaIndex to do that first portion of building up a graph database that is from text. And then we've used Leiden community detection from Memgraph, the new version, to be able to do this hierarchical community detection, the Leiden community detection. After that, what we do is we create community summaries. So for each of those communities that we find, we generate a short summary that describes what's in the community. And then this, in a way, allows us to generalize over different portions of the graph at different levels. And that leads to a more well-connected graph organized by concepts. So again, imagine that you're trying to ask some question about the graph as a whole. Somewhere in the graph, there should be a community that represents links to a large portion of the graph. For example, you would have a top-level community, which is connected to other communities, which is connected to even lower communities, which is then connected to the individual entities within the graph. But hopefully that becomes more clear what exactly I mean later on. So I will just go through the process again of what we did, and then we'll get into the details of how we did it. So we basically start with the indexing process before we get to the querying process. So here we take in some documents, we extract the entities and relationships. That's the object, relation, subject. Then we fill memgraph with those entities and relationships. Then we create node summaries. So basically this is, we kind of expand on the context of the individual entities themselves by basically making more detailed summaries of what the entities are and attach that to the node. This basically just allows us to have a more robust explanation of what the node is within its context. So if, we extract something like Steve Jobs from a text, we might add something to that description on the node itself that represents Steve Jobs that might say something like, Steve Jobs is a tech founder that has started Apple, and it might have some additional details there. So we actually do this as a way to have a more robust description of the entities. Then we perform the community detection with the Leiden algorithm, and we have this bottom-up process where for the first level, we build up a layer of communities where we have the community summaries that describe different groups of entities within the graph. Then we build up the next layer, which is a way that we can group those communities together, which represents a higher level of the concepts that are in the graph. And then we have even another one above that. And then we create embeddings for all of these communities. And all of these communities also have their own community summary, which describes what the community is. And that's literally just a text description that's attached to the community entities and describes information about them so that later on we will be able to search that and find information about that layer or that level of the graph. So moving on to that, we'll talk about querying the graph. So a query comes in, user might ask, what are the main themes of this book if your graph database represents a book or something? We will embed the query. We will search the Memgraph vector index, which again, new feature of Memgraph 3.0, to find different communities that have descriptions attached to them about what those communities represent. And we can also find different entities specifically that relate to that question. All of that context, both community summaries and entities themselves, are passed into the context of the LLM, and then we can answer the user question. So that's basically the process. So the first step, we'll go through a bit more of the details, and I think I'm a little bit behind on time, so I'll try to hurry up. We use this tooling that's an integration between LlamaIndex and Memgraph, where we can basically build up a graph. So we use the Memgraph property store combined with the schema path LLM extractor. This is sort of boilerplate code that you could definitely look up later. And we also have to provide a schema that specifies what types of relationships are allowed, what labels of the entities there are. Then we perform community detection. This is part of the query, but it's not everything. But you can see here that we call this procedure here Leiden community detection. And this is basically the creation of the hierarchical communities that I was talking about before. So each community is represented by a node and is linked to other communities or entities. And each community starts as a community ID, and then we have to basically manually create those links within the graph using some Cypher. But you don't need to worry about those details too much. The key point is that we run the Leiden community detection. We then can build up this layer of communities, and then we can build up further layers of communities. So you can see that some entities here, some maybe people's names, animals, events, those types of things might be linked to a community, and those will be linked to other communities. So now we'll talk about creating those community summaries. How are we actually using those to make summaries and to generalize over that entire graph? So we start from the bottom up. We start with the entities. So we create a short description for each entity and append it as a summary property of the nodes that we just labeled with the entity label. So you can see back to this over here, we will have these different entities and we'll have maybe a title, and then we would also have a description of what these definitions are, or defining these words or the names of the entity. We then also have this community label node, And at first we start at the level 0, which is the first level up of communities. We then need to create a summary of what these entities are and append that to this community over here. So here we can see that this entity here, it's chemistry, mathematics, and engineering would be these entities. And the community summary here would be science. Oh, sorry. And on this side here, we've got a different community, and we have guitar and musician, and these might summarize to being music-related nodes. And then we have science and music on this level, and these are both connected to this community here, and these might be disciplines of study. So this is a very simplified example, but you can imagine this scales out and up so that you might have another layer of community detection, and you would also have many more entities. So let's see. And so the different levels of, move down here, the different number of hierarchical levels depends on the size of the graph. And there's also a parameter that you can tune, which depends, it's called gamma, and that sort of determines sort of the size of the communities that are started out with. And then the final piece here, before we get into the querying the graph, we have to get the embeddings. So in order to be able to fetch those text documents, we first need to create a vector index, which again, new functionality of Memgraph. We can create the vector index using these queries here. We have to specify the correct embedding dimension. And then we just specify which property. So here we have this embedding property, which will be the vector, the name of the vector that we'll need to query later on. And also the name of the property that we'll be uploading the embeddings to as part of those nodes. So we create embeddings for all entities based on the entity and community summaries. So we fetch the text using Cypher, we generate the embeddings, and then we upload those embeddings back up to that node or each of those nodes. So now we can query the graph using vector search. We can search over entities which have very localized pieces of information. But we can also search for information over those communities where we've made those pre-made summaries over those communities already. So we can see, we can ask the graph questions, which means that we can have this global information within the graph that we're able to access. So the key parts of the process are paraphrased version of the user query is turned into embedding, just like regular RAG. We perform vector search in Memgraph with the embedding. We retrieve the relevant entities and community summaries, and then we can get a question answered. So we can have a little look at a demo here. So I've got this little chatbot type thing here, and I've indexed a graph with the time machine by H.G. Wells. And then I can say something like, show me the overall themes. Maybe that's fine. Let's hope the demonstration gods are on my side today. Live demos are always a bit risky. So we can see it says, based on the provided information from the database, the overall themes are, and then it's got this, and it's actually got all the contextual information in the sidebar here that would normally be hidden behind the scenes. But we can see we've got contextual information pasted in the side here. We can see actually text that relates to these community summaries, and you can scroll down, and then we've got many different things. Then we've also got some entities as well, which are there. We could reload this again and then turn off the include communities, and this will only get the entities. So this is sort of simulating if we hadn't done the community detection. And usually when I've tested this, it doesn't give as good an answer. So it does give some parts of the answer, but it has access to limited information and very specific parts of the context. And you can see here, what it has access to is only specific entities, which have been extracted from the text. And it can make some generalizations with that, but it won't be as good. And of course, this will be a compounded issue, for example, if you're working with some type of information that these language models hadn't been trained on. So for example, I'm sure that ChatGPT has access to the H.G. Wells novels. It's probably been trained on it. Whereas if you had some private documentation, this would be an even larger issue. So other considerations and limitations. So entity resolution is limited at the moment. We're only resolving the entities by their names. So as I mentioned before, Steve Jobs and Steve Jobs will resolve, but you might have two people with the same name, and then they might resolve to be the same entity. So this would be something that should be improved on. Tweaking the gamma parameter is something that we sort of have tweaked manually. So that gamma parameter is basically has some effect on the size of the communities. So another problem is the indexing is relatively slow and can be costly when you're first doing that indexing due to the fact that you have to do entity extraction, generating the summaries. Whereas the positive is that over a long term, it could actually improve the costs or reduce costs due to the fact that you might not have to be pasting as much context into the context window when you're doing inference. In our case, we could be using more advanced graph traversing algorithms. So at the moment, it's very straightforward. We're not really taking advantage of the fact that we have a graph database in the terms of that we're not traversing the graph. And there's more, leading on from that, there's more advanced methods of querying and ranking and graph traversal that Microsoft has implemented in their implementation. But that is a little bit beyond the scope of our little demo. Now, I'll give you a quick little show of what I mean in terms of Memgraph Labs. So I can just quickly show you that. I won't go too much into the weeds here, but I'll just run a little query where we could see. Let's see. Try to work out, I think it was this one here that I wanted to run. So all I've done is I have a little Cypher query where I'm basically just querying a chain of the different community levels. So I have a community that's at level 0. So that's the one level up from the entities themselves. Level 1, 2, and 3. And so we've got a couple of chains here. So we can see when I click on this, we'll do full screen. Don't know if that's big enough. Let's see. So you can see this community here, that's level 0. And if I double click that, it's connected to a couple of other entities. So these entities here are Thunder and Sound. And that's connected to a level 0 community. And the summary here says, a group of auditory phenomena characterized by sudden loud noises, thunder and sound. Okay. So that's connected to a higher level community, level 1. And so this level 1 community, you could see this as sort of one level up above the level 0 community, has some other communities beneath it. And then we can imagine that these communities also would have their own entities beneath them, if that makes sense. So we have these entities, level 0, level 1. And that goes all the way to the top. So we can see here that we've got, where is this? This one's level 2 and level 3 should be somewhere. And so you can see this community summary here is very general because it's very high up. We see this collection explores the multifaceted dimensions of human existence. But if you look down, that is all the way connected down to thunder, sound, soft cooling notes, dark gutters, and living beings. And it seems strange, but building up these sequences of different concepts actually generates higher level knowledge when you put them all together to the point that you get something like this. And I think that's pretty cool. But I hope you enjoyed that. That concludes my presentation. So I guess we'll start moving into some questions and answers now.
Sure. Thank you, Jacob. This was great. Let me just fix this screen a bit. Okay. So we have a couple of questions here, and I'm reminding everyone else if they have a question, feel free to ask now. First, we have a question from Veronique. She said, I'd be interested if Jacob could give a little more detailed about how entity resolution was performed. You did mention like being quite simple, but can you tell us more about that?
Yeah, so from what I believe, it's part of the LlamaIndex package that was sort of pre-built already. So that's not something that we worked on ourselves, but I'm quite sure it's simply two entities that have the same name are basically resolved to being the same entity. So it's very simplistic. So that probably wouldn't work in a real scenario if you're really caring about being sure that your entities are not being resolved incorrectly. So you would probably need a more, uh, let's say, a probabilistic model or something that can use a variety of different properties. But yeah.
Yeah, I would agree. Like entity resolution for itself is can be quite a big step in the whole application, and yeah, it definitely isn't an easy. There isn't an easy, quick approach, and with these integrations, they make it easy to kind of get started and try something by yourself. But in the end, I believe that there are a lot of different processes in your pipeline that you would have to do to kind of do that correctly.
Yeah, no, it is a whole thing in and of itself for sure.
Yeah. Okay, we have another question. Any thoughts on using GraphRAG with dynamic data that is frequently updated? Are there ways to avoid completely rebuilding the index every time?
Yeah, I mean, I think a lot of that speaks to whether or not you're using a very dynamic entity resolution process and how that works. So I think that is probably one of the biggest issues with a dynamic graph, as from my knowledge. Um, but you don't need to rebuild the index every time. No, it's definitely possible just to update your graph and add things. That's not a problem. It's quite good with Memgraph. You can do that for sure.
Yeah,
Definitely.
I would say on Memgraph side, you can always do something with triggers where you kind of see what's updated in the graph and update things locally. We all have, also have some ideas on doing these embeddings internally in Memgraph and then having them updated on the fly. That's something we are still kind of considering and working on, but definitely we are aware of this problem of ever growing knowledge and you don't have not having to index everything all the time. I know that's definitely not an easy way to do it, and like our goal is to enable that to memgraph users as well.
Yeah.
Okay, so another question. You also mentioned this, but maybe to elaborate more. So, who decides the entities and relations? Does the user need to do it, or can you throw it to LLM? Like how that works? What would you say? Well, is it good or?
Yeah, sorry, I probably skipped over it a little bit too quickly, but
No worries. Yeah.
probably not giving enough information about where the LLM's involved because it's so core to everything and it's every step of the way it's being used in a slightly different way. So we're definitely using it in the entity extraction. So you would have something along the lines of you'll provide the text and then you'll provide a prompt saying, can you please extract the subject relation object? And then you have something in your prompt that specifies very specifically how exactly it should return the response so that you can extract that programmatically. So, you would have a prompt, you would provide, the sample text, which is, a page of a book or something. You say extract all the entities, relationships, and objects, return it as a JSON format with this schema, and then it should return that. And then you need to, I guess, maybe use regex or something to extract that, depending on how you've done it. Or maybe you don't need to do that. It depends. But yeah, so LLM is definitely used for that.
Yeah, I agree. I mean, it can be used in a lot of ways. Of course, you don't always have that real ability that it's going to be perfect in every step of the way, and having like a human in the loop, especially if you're dealing with your internal data, I think is really valuable.
Yeah.
But also, Llama Index has its own like ways of building this knowledge graph. I remember my colleague Mata was working on this. I think they have that property graph store, and then you can either let it do the job itself, or you can kind of define the schema in advance at least, so you can kind of restrict it to do what you want. So yeah,
Yeah.
that might be helpful.
I think I mentioned it a bit too quickly, but we did use a specific schema, so you can provide that. So, as you mentioned.
Hmm.
And one thing I
Yeah.
didn't mention, which I probably should have, is that which language model you use definitely makes a big difference. So we were using GPT-4o Mini, which is reasonable for our task. You probably don't need something more powerful for what we're doing, but you might just use regular GPT-4o and it might perform better. But then also it's a matter of cost. If you're doing it for thousands of documents, that gets very expensive. So, it's all these considerations as well.
Yeah, definitely. And evaluation is a whole different topic for itself again. So
Yeah.
yeah. Okay, we have another question. Can communities overlap?
Just trying to think. I mean, they do in a sense that the higher level communities have lower level communities beneath them. So a level 0 community is connected to level 1 communities, but I don't believe the communities on the same level are connected to each other, and entities only belong to one community, as far as I'm aware. Someone correct me if I'm wrong, but that's my understanding of it.
Yeah, if someone has a comment on that, feel free to do so. But yeah, I think you said okay.
Mm.
So is it possible to associate certain entities or entire communities with metadata? So Siddharth said, my use case is to be able to disable the usage of certain entities in response generation.
Just have to read that again to.
Yeah.
Sorry. Sort of certain entities. I'm not sure I'm quite understanding the question. I'm sorry.
Yeah, no worries. So let me just check once again. I mean, you can definitely add stuff on top of your nodes if this is what the user is asking for. Like you can add more properties to both community and entity nodes. But to disable the usage of certain entities, I would say you can use, you would have to use a role-based access control. That is, you would have to kind of use a higher security level where you wouldn't allow any user to read a certain labels from the database, from Memgraph. That's kind of part of the fine-grained feature in Memgraph. So in that way, you can say, okay, this user has only right to read these kind of nodes, these label nodes, and then AI also wouldn't be able, if it's that user, wouldn't be able to read that node. So you can kind of limit the AI in that way to have better security on your data. Maybe that answers the question. I hope it does. Okay, we have a lot more. Let me just think. Have you tried Grok with DeepSeek or Llama 3.3?
I have not, unfortunately. I know there was so much hype around, DeepSeek. It's good, but I don't know. It's I'm not really training these large models. I heard it's much more efficient with model training. I still think GPT-4 is better, but and DeepSeek can't
We'll
answer
see. We'll
questions.
see. I mean, everything changes day by day, I would say, in the AI world. Everything new is coming,
Yeah.
and we'll see what's next. Okay, we have another question. Does role-based access control affect performance at scale? I guess that's more like a Memgraph question. I see that our Josip solutions engineer is answering that one, so it does affect, but not by a huge margin. So someone looking for that kind of, and I know that security is quite important in company use cases. So if you are doing a chatbot on your data, and you would have to have a different kind of security permissions for different kind of employees, I believe this is a good feature to utilize. Okay, if I'm not mistaken, well, that's it regarding questions, and there were many of them, and I think they were pretty good. I think maybe a question from my side, Jacob, is what do you think about this approach in general? Before we started this call, you kind of were mentioning, GraphRAG nowadays. We were talking how it's a lot of things. Someone is referring to Microsoft GraphRAG, someone is talking about something else. What do you think about this approach, and if you would kind of do everything all over, would you kind of take a different one? What do you think?
Yeah, no, I think it's a really good approach, actually. I see how it can, generalize over very large portions of information, and it makes it much more efficient for question answering in production, I would imagine. Because I've been building chatbots before, and a lot of the time, if you have something that's a straightforward vector database, you'll have a lot of documents need to fetch, and you might not even fetch the relevant information. Whereas with this, you could definitely it's in a way you're sort of offsetting all of that processing to building up those communities and generating those community summaries in advance, and then you don't have to do it again. So I think it's a really good approach. the thing is, I feel like I would be interested in exploring more what you can do beyond what we've done with that. So I think that's what I've shown you today is really just a good starting point, where it was sort of building up, creating those community summaries, indexing everything. Then what you do after that, there's a lot more to explore in terms of how you're querying the graph and how to traverse the graph and that kind of thing, which I haven't gotten into. And it will be exciting to see how people deal with that in the future, because this paper only came out last year and it feels like a somewhat new approach. I'm sure it's been done similarly before, but it's kind of interesting to see how it's working with all these new language models popping up, and it's getting cheaper and cheaper to run these models, even privately if you want to. Um, yeah.
Yeah, I agree. And so the next step for you is to kind of explore this further, to see like what else can you do to improve this model, and to see kind of like to see also the people. I mean, people have a lot of questions here. I think that's great, and to see the interest in others listening, and for whatever tip they might have in how to improve this. I think that all of that is available.
Hmm.
It's really useful. Okay, I think that's it. So just to answer question in the chat, I think that we will share also the slide deck. Jacob, is that okay with you to share it with the participants?
Yeah, no
Your
problem.
slides? Yeah, sure. Then we'll send the slide deck. You will see the recording. And thank you everyone for asking a lot of good questions. And once again, thank you, Jacob, for doing this presentation. It was really great. I mean, you're a pro. I don't know how often you're doing this, but yeah, you're great.
Thanks so much. Uh,
Uh, okay, cool. And just a reminder, in 2 days, so Thursday, 6 p.m. Central European Time, we have another Memgraph community call, this one with our Tony, head of platform. He will do a demo of Lab 3.0. So you can see all of the new features in Lab, and he'll also do a small demo with a graph chat and AI features. So I guess everyone here also join on Thursday and learn more about different AI use cases and everything that Memgraph has prepared for that. And once again, Jacob, thank you so much for doing this.
Thanks so much for having me. It's been fun.
No worries. Thank you, everyone. Bye.
Take care.